On number 1, you're asked to find the domain, X-intercept and Y-intercept of that rational function. So the domain is all real numbers except what makes your denominator equals to 0. So let's set the denominator equal to 0, and let's solve for x. So x is plus minus 1. So we're not saying the domain is plus minus 1. We're saying x can be anything and everything but plus minus 1. So if you have a hard time writing the domain in interval notation, my suggestion would be to draw a number line and see that, okay, I cannot have -1, so I put an open circle there. I cannot have positive 1, I put an open circle there. So I can have everything else on the number line. I can have this here. So how would I describe that? Well, that's -infinity to -1. Parentheses. It would be brackets if it includes -1. And then this segment is -1 to positive 1. And then this segment here is 1 to infinity. Next, you are asked for Y-intercept. Y-intercept, you just plug in 0 for x. So when you plug in 0 for x, you get 0. So Y-intercept is 0, 0. X-intercept, you would let y equal to 0. Well, if you set this equal to 0, the only time a fraction is going to be 0 is when the numerator is 0. So 0, 0. You may also have already noticed over here Y-intercept is 0, 0. That means it's also an X-intercept. So that's number 1. Number 17. You're asked for to name the horizontal asymptote. Well, for a rational equation, the easiest way to answer the horizontal asymptote question is to look at the leading coefficients. In this case, be very careful. The leading coefficient is -4. Okay, you want to look at the leading term and the leading coefficients. The 3x squared is not a leading term because this has a degree of 2, this term has a degree of 3. In the denominator, the leading term also has a degrees of 3. So if the numerator and the denominator has the same degree, the horizontal asymptote is y equals to the ratio of the leading coefficients. So it will be -4 over 7. So that's the horizontal asymptote. Please do not just write -4 over 7. That's not an asymptote. A horizontal asymptote is a line, and a horizontal line has the equation of y equals to a constant. Next, let's take a look at number 21. In 21, you're asked to do a quick sketch of the graph by doing a quick transformation. So we should know what f of x equals 1 over x looks like. It looks like something like this. Okay, so this -2 means you're going to shift it down 2. That means my horizontal asymptote is now going to be set at y equals -2. The vertical asymptote is still the same. It's still the x-axis. I'm sorry, the y-axis. That doesn't change. So your new graph will look something like this. It's the exact same graph, just shifting it down 2 units from 1 over x. And again, this is the y equals 1 over x graph. Okay, number 33. In 33, you're asked to find all the removable discontinuities and then graph this function. Well, let's factor the numerator. X squared minus 9 is x plus 3, x minus 3. And the denominator is x minus 3, so numerator, denominator cancel. I get f of x is equal to x plus 3, except when x is 3. X cannot be 3, because when x is 3, the denominator will equal to 0. So that's where the removable discontinuity is. When x is 3, you're going to have an open circle. So you know how to graph the line y equals x plus 3. You have y-intercept as 3, you go up 1, right 1, and then you have your line. But remember, x doesn't equal to 3. So when x is 3, you're actually going to have an open circle there. So when you connect your line through, make sure you have an open circle there. And that's what a removable discontinuity is.